Hey YouTube, good evening. My name's Rich. Welcome back to my shop. It's been a while since my last video, but tonight I've got a project to work on. Thought I might try to take some video of this. So over the weekend I picked up this Hamilton 6-inch metal lathe, kind of an unusual machine. These were apparently marketed primarily to vocational schools and high schools and whatnot. Kind of a basic machine, doesn't do any screw cutting or anything like that. I'm going to do another video on this machine and the machines I got with it once they're all kind of cleaned up and fully operational. One of the unusual things about this Hamilton lathe is they were available with a milling attachment that was essentially a milling table that bolted to the left side of the headstock, and then the entire headstock assembly with the motor, and the spindle and the chuck and everything all swilled 180 degrees, and you were able to do milling on that machine. And that essentially mounted kind of over here. This machine is not equipped with that. However, I was able to pick up along with this machine a Hamilton vertical milling machine, which uses many of the same parts that the milling attachment uses, only it's built to be a standalone. So it's got its own motor, it's got a base, and then of course the table and the spindle and the whole knot. And then also at that same auction, I found this very unusual Hamilton vertical milling machine, and that's also, again, not an attachment, that's a complete machine with its own motor. Both of the milling machines have number 1 Morse taper spindles, so they don't run particularly large tooling, but they're cute as hell, and they're kind of interesting machines. My plan is to get these things all kind of cleaned up and restored and make any repairs I need. So back to the lathe. When I went through and inspected the machine, I found 2 problems. I found one stripped out carriage bolt, or I'm sorry, stripped out, I found one stripped out hex on the locking screw here for the compound. I was able to get that out with an easy out. Let me bring you around the back and I'll show you the other problem that I have. So this machine has no real screw cutting capabilities, but there is a lead screw. It just sits on a plain bearing in the headstock, and there's a hand wheel on the end of it. And that lets you use the lead screw for fine feeding the longitudinal feet of the carriage. So it's got kind of an unusual half nut setup. I don't know if you can see that here. So essentially, this little guy rides up and down in this carrier, and there's a lever that moves it back and forth to adjust it up and down. And then there's the half nut here that rides on top of the lead screw to drive it back and forth. There was some play in the lever assembly, and there's some detents for a ball bearing, and I thought that was a problem. I did some work on that, and it turns out that this little half nut here is just kind of worn out. It doesn't really make good engagement with the lead screw when this is all the way down in the lock position. So the plan is to make a new half nut here, and unlike most of these, typically when you see the half nuts, there's 2 parts that sort of clamp together on top of the lead screw. This is just a single part, and it's just forced down onto the lead screw to drive it. So I had a go at making this earlier in the day, actually. I went ahead and measured the screw, and I was happy to find out that it's just a half 13. I have plenty of half 13 taps, so I went ahead and I started making this part here. Unfortunately, when I first made it, I milled it to size, which is 1/2 inch all around, and then realized that I was going to have a hard time getting that tap in there because obviously it's going to be sort of the full width. So I backed it up with some aluminum pieces, and you can see it just made it. There's some little grooves here, and the intention was to take this, rather this way, cut this off, mill the diagonal slot in here like this guy has, and then face it to size. Unfortunately, when I went to go test this part on the lead screw, it wouldn't start no matter what I did. I went and put a chamfer on there, and I checked it with a plug gauge, and everything looked good, but no matter how hard I tried, it wouldn't start onto the lead screw. And it was at that point that I realized that the lead screw is a left-hand thread. I do not have any left-hand taps. So tonight what we're going to do is we're going to remake this part. I'm going to find another piece of brass, and then we're going to put this in the four-jaw chuck in the lathe, and we're going to single point and inside left-hand thread. So that's the challenge for tonight. I'm probably going to go ahead and just face the bar to the right thickness. Use whatever width I happen to have laying around in stock here. And then once it's bored and threaded, then I'll go ahead and put it in the milling machine and bring it down to the final size. After that, we're going to put the slot in it. I haven't decided if I'm going to use the shaper for that or if I'm just going to do that in the milling machine. Let's see how we feel when we get to that part. All right, so I'm going to go hunt down a piece of brass, and we'll meet you over at the lathe. Okay, so I went rooting through my box of scraps, and I came up with this piece of brass. This is actually the nut from an old Atlas shaper. The threads are kind of a bit bollocksed up. I don't have any square stock that's really close to the right size. Everything I have is way too big, so this is more than big enough. The part we need is just about a ½ an inch square. It actually measures out about 0.498. This is well big enough. The part here that's uncut without this taper on here is long enough. So we're going to go ahead and pop this into the horizontal milling machine and just square it up a little bit, and that'll give us a good surface to grab with the forge once we get into the lathe. All right, so we're going to go over to the milling machine, put this in the vise, and square it up. Okay, so we're here at the Atlas mill. I'm just going to go ahead and put this in the vise. Just kind of center it up here. Lock it in real good, give it a whack. Now, one thing you don't want to do on these Atlas horizontals is you don't want to go ahead and climb mill on these because they will chatter like mad. Something I discovered not too long ago when I accidentally started climb milling on there. So we're going to go ahead and just touch off on this. I'm going to bring this table down a little bit. Crank this in. Oh, and there's some trouble right there. So this vise is a little too large for this machine. You can see it hangs up back past the back of the table a bit. And that limits my travel here, being able to get all the way back here. So I'm going to go ahead and pull the arbor out. I'm going to swap these spacers around so I can bring my cutter closer to the end of the arbor here, and we'll try again. All right, so we rearranged the spacers. We brought the cutter out further along the arbor here, so now we got plenty of travel on the vise. I've got it roughly centered over the top of the part here. Now we're just going to turn the mill on, and we're going to crank the knee up until we just touch, and then we'll go ahead and back the table off to the right, and go ahead and cut a flat on that. I guess we're going to probably take about, oh, I don't know, maybe just 30 or 40 thousandths just to get it square. So we'll go ahead and touch off, and then off we go. All right, probably a little quick there, so we're going to back that down a little bit. Oop. Bring this guy back, and then we'll go ahead and crank in about, oh, I don't know, 30 thousandths. 10, 20, 30. That should give us pretty good flat. Maybe I'll go 35. Lock the knee. Now, when I got this machine, the power feed wasn't working. There's some gears in here that are kind of fragile, and they have a tendency to go bad. So I recently replaced those. This will be the first time I'm using the power feed on this machine, so fingers crossed. Here we go. Well, one thing that would be definitely useful is to go ahead and actually set the power feed lever so that it feeds in the right direction. This is a pretty slow feed. This is about the slowest feed this machine will do. But we're in no hurry tonight. We're going to have to take our time and let it go. We're just not coming up on the cut. There's an awful lot of chatter on there. I'm not quite sure why. I was cutting similar material earlier. I'm not too happy with that. That's making an awful lot of chatter and a lot of vibration. Normally this machine cuts just like butter. So I don't know, maybe this piece of brass is just harder than I thought. Well, it's just barely cutting. Cutter is nice and sharp. This is a brand new cutter. I've only used it a couple times. Well, let's think about this. I'm going to go ahead and regroup, maybe try to find a different piece of brass and start over again. Back in a minute. Okay, so we switched to plan B. I fooled around a little bit over on the horizontal mill. I wasn't able to get a cut that I thought was really satisfactory. So I'm here on the vertical milling machine. Got it in vise, got a 2-flute cutter here. It's nice and sharp, and this should do a good job on here. Also give me a chance to try out my new toy. I recently fitted this machine with a 1.5 horsepower Baldor DC drive motor and a variable speed DC controller on there. So using the pulley setting that nominally gets you 1,000 RPM with a 1,700 RPM motor, I can get down to a little under 300 RPM up to a little over 2,000 RPM without changing any belts. And changing the belts in this machine, it's kind of a pain. You have to loosen a bolt here, and this whole motor assembly slides on the column. It's really heavy, it drags a lot, and it's kind of time consuming. With the variable speed drive, turn it on. That's about 250, 280 RPM. And that's 2,000. So sure, probably not as good as a 3-phase motor and a VFD, but it definitely gets the job done. It's a pretty heavy duty motor. I did some testing on here and I was not able to get it to even show any signs of slowing down, let alone stalling. So anyway, I went ahead and touched off. I dialed in about a 35 thousandths cut. We're going to go ahead and flatten this piece out, and then we'll chuck it up on the forge on the lathe and get to work. So here we go. I'm at about 800 RPM here. That's a pretty good finish. I'm going pretty fast here. Go ahead and crank in about 50 more thousandths. Take another pass. Interrupted cut where that thread is. That may be why the other milling machine was complaining so much. I don't know. That finish looks great. Unfortunately, it didn't quite clear off the whole thing. I'm going to go ahead and pull the table in, put it back to center, and just go ahead and run back the other way. Put some chips off in here. And that looks perfect. All right, so we'll flip it over. Just give a little tap through there. Get centered up here. And we'll go ahead and take a pass. Oh, no, we won't. This bar must be tapered a bit. It was a tight fit when the machine, when I went and got it out. Go ahead and crank up another 50 thou or so. While I'm thinking about it, put the old table guard on there. I'm trying to keep some of the chips out of there. All right, so I'm going to crank up about 50 more once I pick up my handle. And on this machine, 50 thousandths is essentially one turn of the handle. So there you go. And we'll come across again. I'm going to go ahead and feed this in a little bit, just to kind of get to the edge. And then we'll feed towards us. And we'll finish doing it. Probably should have locked the table. I'm getting a little bit of variation in the finish here, but that's okay. I'm going to end up probably facing this off on the lathe before I cut it anyway. Oh, got a big chip on the end there. I got to deburr that. All right, so I think that's good. I'm going to go ahead and probably just leave it at that. Actually, I'm going to face the ends off to clean them up. And I'm going to chuck it in the forge on this edge, and we're going to go ahead and face the whole thing off flat in the lathe. All right. So let me do a little deburring on this, and we'll reconvene back at the lathe. All right, so I'm going to go handheld for a minute here, so my apologies if it's a little wobbly. So I've got a piece in the forge chuck. I've got it more or less centered across the width here, so I can drill my hole kind of in the center. It's not super critical at this point because this whole piece is going to get milled down to just about ½ inch, about a thousandth or two under ½ inch, so it slides in the groove. I wanted to make sure that I was as far up the bar here as I could without running into this old hole, because that's how it's going to get chopped off there. Leaving myself enough length here to be able to trim that off. So I'm in the chuck. It's a little off center. I don't think it's going to vibrate too bad. I'm turning pretty slow. I'm about 300 RPM, so we're going to go ahead and turn it on and just see how it looks. And that looks just fine. So now we'll go ahead and grab a center drill. We'll center drill that. We'll drill it out and cut our thread. Alright, so my tripod doesn't fit in the corner here. My shop is a little tight around the corners, and it's also a huge mess at the moment. So I'm going to go ahead and center drill this first. Pardon my reach if I'm in the way here. Go ahead and pop that in the tailstock. Lock her down. Before you do this, always make sure and check that you're going to clear the carriage, which I'm not going to do here. So let's see if I got enough space here. Yep, that should be good. I checked that I cleared the bed, but I neglected to check that I'm clearing the carriage. So let's go ahead and try that one more time. And I'm right in the way. Oh well, sorry about that. All right, so we'll get a good center drill on that. And we'll back that out. We'll change chucks here, and we'll grab our tap drill. Okay, so of course my battery died just as I started to go ahead and get ready to center drill and drill that hole. So I figured you guys have seen enough people drilling holes on the lathe on YouTube already, so I went ahead and did that off camera. It was pretty drama-free. I went ahead and put a center drill in there, and then I grabbed a 27/64 drill, which is the tap drill size for a 1/2 inch 13, and got some nice big long spirally chips out of it. Everything went good. So now I went ahead and set up a threading tool in a tool holder here. I've got it set on center height, and then because I'm concerned about running into the carriage again, I went ahead and set a stop, and all I did was I took a scale. I measured my part here. It's about 5/8 of an inch deep. I made a mark on the tool at about 7/8, and I ran the tool all the way in, and then I went ahead and put a carriage stop on there just so I don't have to worry about any issues there. So this is going to be an inside left-hand thread. This is only my second opportunity of cutting inside threads on the lathe, and the first time cutting left-hand threads. So my chances of success I would rate at about 50-50. I should have started with my standard disclaimer. I'm not a terrific machinist. I'm very much a beginner and just learning this. So this is going to be a little bit of an adventure, and I'm going to take it slow. Everything is going to be kind of backwards here, a little counterintuitive, so I'm just going to kind of really take my time. I've got the lathe in back gear at my slowest speed, and we're going to go ahead and do it. So I'm going to start by, so I went ahead already and I touched off and I set my zero on my dial here, and then I'm going to go ahead, I'm going to feed the carriage into the inside of the part. I'm going to advance, I'm going to back my counter, let's try that again. I'm going to back off towards me on the compound about 5/10ths, and I'm going to go ahead and throw the half nut and take a pass. 13 threads per inch. I'm going to go ahead and always pick number 1 here on the threading dial. I'm going to make sure that's well engaged. And, well, that's about all there is to say. So here we go. So I'm going to feed in all the way. I'm going to make sure I'm clear, which I believe I am. I'm going to start the lathe up. I'm not getting good engagement on my threading dial, so I'm going to go ahead and just snug that up a bit before I go any further. So I'll be right back on that. All right, so my threading dial is a little loose. There's a set screw that goes in here that keeps it from rocking back and forth. You know, this lathe was made in the United States of America in the early 1970s, so of course you'd expect this to be a standard thread. I don't know, maybe a 1/4 or something. And I got a box of about 500 set screws, and not one of them goes in here, so I have a feeling that's one of these South Bend oddball threads. I'm probably going to go ahead and run a drill through here and drill and tap it 1/4 so that I can put a set screw in. But in the meantime, it's fairly snug. It's moving along with the carriage just fine, so I don't have any problems. So we're going to go ahead and make sure that's snug, double check all my settings, make sure I'm just touched off here, and then we're going to come back and start the thread. All right, so I was just going to catch number 1 every time around, just to be safe, but then I remembered I've got the South Bend How to Run a Lathe book. This is invaluable if you want to run a lathe. And I turned to page 54 of the thread dial, and it reminded me that for any odd threads, I can close the half nut on any numbered line on the dial. So that's what I'll do. All right, so I'm zeroed, I'm touched off. I went ahead and zeroed both dials here. I'm just going to clean that one up. And I'm set for 13 threads per inch on the gearbox. So I'm going to turn the lathe on. I'm going to back the compound towards me about 3/10ths. I'm going to take a cut, and we'll see what happens. So I'm going real slow here. Here comes number 2. Throw the half nut. And we're just barely making a scratch, which is fine with me. And like I said, I'm going real slow here. Alright, and we're through. So we'll throw the half nut. I'm not too thrilled with the way this thread dial's engaging here. It's making me a little nervous. Well, I guess it's okay. Alright. So I'm going to feed in just about 50/10ths. Go ahead and run myself into the stop. I'm going to feed the compound out about 5/10ths. Come back to 0. Alright, I missed number 3. We'll wait for number 2 to come around. It's coming. Here she comes. I might just speed this up a little bit once I get into the groove. I don't know. I'd rather wait, I think. Here comes number 2. Throw the half nut. Alright, we're coming out. I don't hear it cutting, but this is a pretty small tool bit. It's a 3/8 tool bit that's been ground down. Put a threading tip on it. And maybe a bit of flex in there. So I'm in no hurry here. I got some chips. So that's a good sign. Alright, we're out. Feed in. Back to the stop. back out to 0. I'm going to put maybe 8 thousandths on this time. Here comes number 4, and we'll throw the half nut. Well, we're going to be here for a while, so I'm going to go ahead and keep going, and I'll check back in when I start seeing some signs of a decent looking thread in there. All right, wish me luck. All right, so it looks like a thread. That's a good sign. I'm definitely making progress. I've taken, I don't know, 6 or 8 passes. Occurred to me about halfway through this that I do not have a left-hand half 13 thread gauge of any sort. I suppose I could look in Machinery's Handbook and try to figure out what the depth of the thread needs to be, figure out what the travel on the compound is going to be at 60 degrees to get that depth of thread, and kind of go from there. But I had another idea. I'm going to go ahead and yank the lead screw off of that machine. It's a 1/2 inch lead screw, so it'll fit through my spindle, and then I'll go ahead and run it through the back of the spindle into the part and use it as a gauge. So I'm not quite there yet. I'm going to go ahead and take a few more passes, and I'm going to go ahead and grab the lead screw and give it a check. So back in a few. All right, we're getting kind of close, I think. Here's my thread gauge. This is the lead screw from the lathe. I went ahead and brought it in through the spindle, loosened it, since it's the left-hand thread, and I can feel it engaging, but it's not going yet. So I'm going to go ahead and probably take, I don't know, 2 or 3 more passes. There's definitely a bit of flex in the tool. I took like 3 spring cuts, and I was still peeling off just the slightest, hair of a chip. So the thread looks good. We're just not quite all the way to depth. So a few more passes, and we'll check it again, and we'll see how it turns out. All right, we're definitely getting close here. So this is just a spring cut. You see, we're definitely getting some chips out of there. So I'll go ahead and take a few more until it cleans up, and then we're going to go ahead and test our fit again. All right, so I took a couple of spring cuts till I stopped getting a chip out of there. My thread gauge. I'm going to go ahead and put it through the spindle. Now, I could run it through this end, but then I got the carriage and the tailstock and everything in the way, so this isn't too bad. It just takes a second to get it lined up. Luckily, there's a nice long lead on that. All right, and then let's, oh, look at that. That's a perfect fit. It's just dragging a little bit, which is fine, because this is a brass nut on a steel screw, so it's going to wear. I'd rather have it start off just a little on the snug side and have it wear in. So I think that this operation was, much to my surprise, and probably to yours too, a rousing success. And that's it. That's the thread all the way through. All right, so that looks good. So now the next thing to do is to take it out of the chuck here. We'll go ahead and put it back in the milling machine, and we will bring this part down to size. Like I said, it's got to be $4.99. I'm going to make sure I figure out how to center on this hole here, side to side, front to back. Obviously doesn't matter. And then once I get that done, then what I'll do is I'll go ahead and I'll put the that slot in there at the proper angle, and then I got to cut it off halfway across the thread here. I got to measure that. I'm not sure it's exactly halfway, but there's a little bit of long as it's pretty close, I think I'll be all right. I want to make good engagement on the screw. So, all right, that's the end of the lathe work for now, and we will regroup back on the milling machine. So before I take this down, I just want to give you a quick shot of the tool that I was using. It's just a piece of 3/8 inch high-speed steel, and is that a good gauge? You can see it's got a 60-degree point ground in there. I wish I could take credit for grinding that, but I didn't. This is one that I picked up in a box of tooling that I bought at an estate sale or an auction. And usually when I get a big box of tooling, what I do is I go through them all. I pick out all the ones that are already ground at 60 degrees, and I got a drawer that I keep all my threading stuff in there, my fishtails and thread gauges and all that good stuff. So that's all it is, just a little inside boring bar, and I will definitely call that guy a keeper. That worked like a charm. All right, over to the mill. Okay, so now my challenge is to get this part milled down to size. It's got to be just about 1/2 inch, 500 thousandths. This is the original part, and The hole is not bored directly in the center of this bar. I just sort of approximated it because I knew how to take this thing down anyway. So what I want to do is I want to figure out how much has to come off of each side. And to do that, what I've done is I've run the lead screw into the part. The lead screw is resting on the jaws. This is the original part. I'm going to go ahead and engage that into the threads in the lead screw. Make sure it's in there nice and snug. And then I'm going to go ahead and I've got the indicator on that part. I'm going to zero the indicator. Oh, this guy's a little on the sensitive side. So that's 0. So that's where this part needs to be to the finished size. So now I'm just going to go ahead and take this part out. I'm just going to run my table back until I hit the top of my part. And I'm at about 890. So I'm pretty happy with that. I'll grab a piece of paper. I'm going to write down 890, and that's going to be how much I need to take off of that part to get it down to the right size. Once I have that done, I'll go ahead and do that. Once I flip it over, then I'll be able to just go ahead and indicate from the bottom of the part and make sure that it's going to be 1/2 inch. So 890 is my number, and that's what we're going to do. I just wanted to add, that's actually 89.0, not 890 thousandths. This guy reads down in tenths, so 0.0890 is my number. Okay, so I got the part mounted in the vise here. Going to just touch off here, start hogging off material here. Going to take off 0.0890 as my final number here. So let's go ahead and start it up. We'll go ahead and touch off. I'll probably take this in about 50 thousandths passes at a time here. And let's see, here we go. Set 0. Crank it up 50. Right, take a pass. Finish on there. Alright, so that's 50. Got 39 to go. I think what I'm going to do is I'm going to take 35 off, and then I'll go ahead and leave the rest for a finish pass. So there's 10, 20, 30, 5. I'm going to come up 4 more, and I'm going to lock the table so that I get a nice and even finish across the back there. Alright, so that's 4 thousandths. Lock the knee. speed that up just a little bit. That's leaving a pretty good finish on that. Alright, so you can see a mark where my two passes were made, but you can't feel anything. That's real close there. So now I'm going to take the piece out, and what I'm going to do on the other side is I'm just going to flip it over, and then I'm going to take the original part, lay it on the jaws of the vise, get my indicator back out again, you know, find the height there, find the height on the other part. We'll subtract the difference, and that should get me to my finished dimension. All right, so let me grab an indicator, and we'll get this flipped over. Okay, so I've got the part mounted in the vise. I've got the original part here sitting on top of the same parallels, and I've got my indicator here. So again, we're just going to set 0 on that, and then we'll take the indicator, run the part up underneath it, and we are showing 226.5. Just going to go ahead and check it down a little further here. 224.5. So, all right. So we're going to go ahead and take off. I think I'm going to take off like 222, and then what I'll do is I'm just going to go ahead and take this part, and I'm just going to check it against here, just by eye, because again, this doesn't have to be within, you know, a 10,000th or anything. There's a little bit of a sliding fit in the carrier, so you know, if it's a tiny bit too small, that's fine. If it's a little bit too big, it'll bind up, and I can always just lap this down a little bit to be smooth. So 0.224. We'll go ahead and take 2.222, and let's see where we end up. So let's go ahead and get that set up.